With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello yet again, and thank you for joining us on another edition of the Space Nuts podcast. My name is Andrew Dunkley, your host, and with me is astronomer at large, Professor Fred Watson. Hello, Fred.
Hello, how are you doing?
I'm well, thank you, sir. How are you?
I'm all right, thanks. Yep, all good.
When was the last time you were at home?
Very briefly, a few nights ago, but it was far too short. But I'll be there again soon.
You're in the wonderful city of Canberra now because they can't do anything there. The capital of Australia, the centre of our political world.
I cannot possibly comment on that.
Well, that's because you still work for them.
I know.
I used to, but I don't anymore.
Yeah, well, you're all right.
Yes. Now,
but I'm still getting paid.
All right, we will dodge that rather dicey subject. Today, though, we're going to be talking about one of the great names in space history, and that is Alexei Leonov, who has just passed away. We're going to talk about what he did and what it did for humanity in the space race. We've also got some news on Venus. Now, we talked about Venus the other day, and we're fascinated to learn that it may well have been a planet that was not unlike Earth at some stage. Well, now they've got a bit more information that focuses on lava flows. And even though we can't see them, we can see what they looked like and glean a lot of information from those lava flows, which adds even more potential to the fact that Venus may have been a planet that could have had life at some stage. Maybe. We're also going to answer some questions. One from Barry about planets being too big to get off. Questions about the danger of black holes floating around our solar system or our galaxy, and Mars quakes, all coming up on this edition of Space Nuts number 175, Fred. Oh, my gosh. It's a good thing we do one every day. Otherwise, we could have been sitting here for a very long time.
We could have been, that's right. Yeah.
Yeah, actually, we do them once a week, and sometimes we do 2 or 3 a week because sometimes we just can't get together. It's a strange situation, but that's the beauty of podcasting. You can do it any time and
any place.
Yep. Not like radio. You've got to be there at the right time to get on the radio so you don't miss your deadlines. Anyway, let's go to our first topic, and this is the passing of Major General Alexei Leonov at the age of 85. What an amazing man.
He is an amazing man, that's right. And one, I guess, whose achievements maybe got overshadowed by the subsequent lunar landings, because he made history on the 18th of March, 1965, by being the first human to perform a spacewalk. So he was in a capsule called Vauxhall 2, and he basically pulled himself out of that in his spacesuit. He had a 5-meter long tether, so he didn't just float off into space and never be seen again.
I hope it wasn't made of the same stuff that my painting had holding it up because it crashed to the ground last night and smashed into a million pieces.
Ah, that's a bit of a shame.
Yeah, the funny thing is, we both heard it and we both looked around the entire house, couldn't figure out what it was, figured it was just a seismic anomaly, and then we found it this morning. So, hopefully the tether wasn't made of that stuff because not good. Not good.
No, well, you can see from the images there is footage on a number of websites, and the tethers are pretty thick. In fact, they look to be about a centimetre or, 2/3 of an inch, 2/5 of an inch in diameter.
That's too scary to contemplate.
They're big. It's too scary to contemplate them breaking.
Yeah, I'd want a rope at least as thick as my forearm before I ventured out into space.
Yeah, that's right. You would, of course. But what I had forgotten, I probably did know this on the 18th of March, 1965, but his spacewalk was actually televised live and broadcast on radio, which gives you an idea of just how confident the Soviet Union were in their space technology at that time. And I guess you could say that in March 1965, they were ahead of the game. Because they had a two-person spacecraft. Now, I will need to look up, and I'll try and do it very quickly, when the first Gemini space flight was, and Gemini, of course, was the US two-person spacecraft, or sometimes called Gemini.
Yes.
Depending
on what part of the globe you're from.
Yeah, I've Googled that and got my weekly horoscope. There you go. That's the way these things go. Gosh, this is terrible.
Well, let me try and find it for you.
But it was about the same time. So the Gemini program was roundabout. It's
1961 it started.
Yeah, but when was the...
and the missions were 1965 and 1966. So it was around the same time.
Yeah, but was it before the 18th of March? That was what I was trying to Google. In any case, it means that the Soviet Union with their Vokshod capsule were doing very well at the time.
Gemini 1, April the 8th, 1964.
There you go. Okay. Did that have people in it?
I don't know yet. I'm still looking. See how much research we do before we actually start recording?
We're all so thoroughly prepared when we do these podcasts. But look, whatever the situation was, he clearly made history. First spacewalk. I guess you could say that at that time, the Soviet Union's and NASA's human space programs were pretty well neck and neck. But throughout the 1965, 1966, the Gemini project, absolutely, I think in many ways it stole the show because there were 12 Gemini missions, I think, and they basically learned how to rendezvous in space, how to send multiple people into space, how to spacewalk. There were spacewalks by the Gemini astronauts as well. So I think that's probably the point at which NASA overtook the Soviet Union in human space flight.
Why did the Americans end up winning the space race and getting to the moon and putting people on there first? Because the Soviet Union had a brilliant head start and absolutely nailed it, and then all of a sudden they got left behind.
Partly, I think one of the reasons is that there were. In some ways, it's a bit like the Americans were before NASA, because until 1958, when NASA was formed, you had multiple, basically, arms of the military, all doing different things in space or trying to, and there was competition between them rather than cooperation. And it was the Soviet Union's success with Sputnik 1 in 1957 that galvanized the Americans into thinking, well, we've got to get everybody together on this rather than compete. What we need is a space agency, and that was fine. It took off from there. Yeah. Whereas I think that element of competition prevailed for much longer in the Soviet Union, and there were particular rocket engineers who had very differing points of view, and they were, basically vying for supremacy in building Soviet rockets. And it was only in, I think it was 1965, when the Soviet N-1 program was introduced. N-1 was the equivalent to the Saturn V. It was a gigantic 100-meter tall rocket stack, which was planned to take 2 astronauts to lunar orbit and put them down on the moon's surface with a rover, unlike the 3 going to lunar orbit with the Apollo program. So I think it was partly the internal squabbling that slowed down the progress of the Soviet Union and allowed NASA to push forward. Technology-wise, they were actually ahead of the game in some ways. The N-1 program had some very advanced hardware as their first stage rocket motors, probably more advanced than the Rocketdyne, the giant Rocketdyne engines that the Apollo system had, the Saturn V. But there were 30 of them. I think it's 30 on the first stage of the N1. And when you've got 30 of these things all going off together, it introduces all kinds of vibrations and horrible things like that, which I don't think they ever managed to solve. So. Yeah. That program was wound up. We didn't find out about it in the West until the wall came down, until the end of the Cold War.
1990s, yeah.
1989, that's right.
For the record, Gemini 1, Gemini 2 were both uncrewed. Gemini 3, launched on the 23rd of March 1965, had on board Gus Grissom and John Young.
There you go. So the Russians were ahead.
Yes.
The Soviet Union ahead by 5 days.
By 5 days. In fact, I think in the movie The Right Stuff, they portrayed that very close fought battle to get the first pairing in space, and the Russians won by 5 days. But I guess it also indicates that the Americans were catching up incredibly fast. There's another interesting aspect to this story involving Alexei Leonov, because during the height of the Cold War, there was this fabulous mission involving NASA and the Soviet Space Agency, where they basically docked between an Apollo probe and a Soyuz probe, and Alexei Leonov was on board that mission.
He was, that's right. So the Apollo Soyuz, exactly. Fantastic stuff. I remember when that happened, this was I think mid-70s, 1975, thereabouts. I thought this is fantastic that the Soviet Union and NASA are cooperating in space. It was really great news, and led, of course, eventually led to the International Space Station.
Yeah, and another interesting sideline to this, and this is sort of bringing in my radio career. I was a big fan of an Australian band called Sherbet, who were big in the 70s, and they released an album in 1975 called Life. And as well as doing rock and roll music, they sort of ventured into an area of experimental sound and experimental music, and they actually used audio from the coupling of the Apollo and Soyuz probes and the meeting of the astronauts in the music. And it really does sort of it really is a haunting piece of audio. Yeah. If you've never heard it, I would suggest getting a hold of Sherbet's Life is for Living album and listen to the Survival reprise at the end of the album, because it's got that audio in it and it just sounds fantastic. It really is. Really is. Yeah, I've got the album. I play it every so often because I adore it so much. But yes, just remembering the great man, Alexei Leonov, and I understand that he will receive a burial at a military memorial cemetery outside of Moscow. One of their national heroes, no doubt about it.
Yeah, and actually a national, a global hero in space. Oh, indeed.
Yes. Yeah. I think we should be more and more cooperative in our approach. I know they were rivals through the 60s and 70s, but these days the cooperation in space is a good example of where humanity should go, I think.
Quite so.
At least on the civilian side of it. We don't know what's happening with military.
That's right.
Don't want to go there. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson, of course. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated number one by Tech Radar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
3, 2, 1.
Space Nuts.
Now, Fred, our numbers on YouTube are rising. We're trying to reach the magic number of 1,000. Our producer, Hugh, seems to think that that's special. We've got to get to 1,000. So, I'll take him at his word. I don't understand YouTube all that much, except that I occasionally watch videos on it. But we are up to 435 subscribers on YouTube. So if you would like to follow us on YouTube and listen in that way, if that's your preferred platform, then go to youtube.com/C for Charlie/Space Nuts. And that's where you'll find us. All our episodes, our entire back catalogue is on there. And you can listen anytime you like via YouTube on your computer or your smart device, whatever. I'm sure you can Bluetooth it through your car. It's a very convenient way to listen to YouTube. YouTube's obviously trying to stay ahead of the game with so many podcast platforms out there. I think we're pretty much on all of them. So it's your choice. But if you can help us get to 1,000, that would be awesome. Now, Fred, some new insights into the habitability of Venus. Now, we did talk about this a couple of weeks ago, and we came up to the realization that there were potentially 3 planets in our solar system that could have, would have, may have been habitable at one time or another in the history of our solar system, and Venus was one of those. Now there's more evidence coming out of an old mission that is starting to suggest.
With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.
Even more likely.
Well, I think it's going the other way.
Well, it depends which way you read it. I mean, they're talking about lava flows and how they were created and suggesting water may not have existed when they thought it did. So, yeah, that's right. Kind of the downside on it.
So, it's an interesting story, and it is some very nice work that's come from the Lunar and Planetary Institute in Houston. Scientists there have, as you said, analysed data from an old spacecraft, Magellan. It was in orbit around Venus from 1990 to 1994. It was basically, if I'm right in saying that, it was the first spacecraft to orbit Venus. It's a NASA project, and it was equipped with radar, and that gave us our first maps of the surface of Venus, because of course Venus is covered with opaque clouds. The resolution was something like 70 to 80 meters, that sort of level on the ground. So, but that's the only information, or the best information, that we've got. I should acknowledge that this has been very nicely written up, this story, by Richard Lovett, who's a very prolific commentator on space affairs. So there's a very nice article by him online. And what it's saying is that this research basically has looked at a particular lava flow, which rejoices in the name of Ovda Fluctus, or Oda Fluctus, depending on how you pronounce it. Fluctus is a flow. It's just basically a lava flow, which has been thought to be a flow of granite, basically, granitic lava. And the reason why people thought that was by looking at its shape, because the other kind of lava, basaltic lava, is of a different viscosity, and so a lava flow will produce a different shape. So the granitic lavas, and they include rhyolite, which is a fairly common igneous rock, they're very, very viscous. In fact, the scientists who've done this work liken it to bread dough. Bread dough's pretty viscous; it doesn't flow very easily. Couldn't really drink it. Whereas the basaltic lavas are much more fluid. So, if you look at a lava flow, then and in particular look at the edges of it, where as it cooled, it basically froze, and so that gives you a kind of snapshot of how it was flowing at the point at which it froze. That's why you look at the edge of a lava flow. And people doing that some years ago looked at it, thought that this was a granitic lava, perhaps rhyolite, and that's important because that sort of lava is rich in water. There's a strong water content, and that's why the lava flow was taken as being evidence that Venus once had water on its surface. Mm-hmm. So what has now happened is that this radar imagery from the Magellan spacecraft has been reanalyzed, and in particular, one of the contributors to this was an undergraduate student intern, and great stuff. Students get the best ideas on that. So they looked at the edge of the lava flow, but rather than just looking at it and saying, "Oh yeah, that looks like granite," they basically analysed it mathematically, because the edge of a lava flow is a fractal in shape, a mathematical fractal, which you will remember is one of these shapes that no matter what scale you look at it, it basically has the same characteristics. Whether you're looking at the overall large scale or down at the detail, it's got the same mathematical characteristics, which is what makes it a fractal. So they've analysed these fractals, looked at the numbers, and what they get is that this is unlikely to be a flow of granitic lava. It's more likely to be basalt. And basalt forms in the absence of water. So the suggestion is that maybe this formed under dry conditions. Now that, I guess in the big picture, really doesn't tell you anything, because Venus is a big place. Yeah. It's got far more land area than the Earth has. It's the same diameter as the Earth, but of course there's no oceans on Venus. So there's a huge amount of the planet, and we're kind of drawing a conclusion from just one lava flow. But very interesting that it comes out, since you can't, you're almost clutching at straws in a way. You can't go down and decide what this stuff's made of. You've got to use whatever bit of evidence you can. And fractals at the edge of the lava flow is as good a way as any, because you're not going to get much better than that. For that to conclude that this is a dry basaltic lava, I think that's, it's a contribution to what we know about Venus. But does it have broader implications? We don't know.
And yet they're not suggesting that Venus does not have granitic lava or granite.
No, that's right.
There's also a sort of a caveat in the explanation to say, however, we're not saying there was never water on Venus,
that's
and
right.
If there was water, there's every possibility that at that time, and the sun being a little bit cooler then, it could have harboured life. They haven't dismissed that possibility.
That's right, and in fact, they say, one of the authors says it's most likely that Venus does have granite, and therefore proof of water. But there's the thing is, there's a lot of Venus, and this is just one very small, very very small area. So they're not giving up on the idea that Venus could have had life billions of years ago. And the more work that's done on this, the more interesting it gets. Of course, another mission to Venus, to land on Venus, would be a great thing to do, but that's actually not very high on the agenda.
We're focused elsewhere, aren't we?
We are focused elsewhere. That's right.
Dumb question from nobody I particularly know, but do we have those variable lava flows on Earth?
Yes, I think so. I think there's both kinds here on Earth. That's a good question. The Earth's volcanic regions basically give you all kinds of different lava flows.
And which one's the speedier, sloppier one?
The sloppy one is basalt.
So that's Hawaii's predominantly basalt, I'm assuming?
Yes, that's right. There's the shield volcanoes they're essentially basaltic.
Yeah, that's been a very active place for a very long time, and quite an amazing place to visit too.
I mean, that's your comment there is a good one, because you've only to think of the fact that the Earth has this rich variety of different kinds of geology. And if you try to draw a conclusion about whether there's life on Earth from just one lava flow, we'd all fall about laughing.
Yeah.
It doesn't really prove one thing or another, but it is, I think, an interesting piece of work and a nice result.
Indeed. Okay, you're listening to Space Nuts. Andrew Dunkley is my name, and of course we're with Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
And a big shout out and thank you to our patrons again, Fred. 61 people have signed up on Patreon to support our podcast, so we thank them for that. And if you would like to do the same, patreon.com/spacenuts is the place to go. You can sign up for as little as, I think it's $3 a month or something is the minimum, and right up to $20, but it's up to you. You don't even have to do it. It's just something, if it's something you would like to do or consider doing, it would be greatly appreciated, but it's not mandatory. You can still listen to us either way, although we are trying to introduce benefits for Patreon members. So it's patreon.com/spacenuts. Now to some questions, Fred, and our first one today comes from Barry Thomas in the cloudy place called Melbourne, down in southern Australia, southeastern Australia, the state of Victoria. Hi, Barry. Thanks so much for your question. He hopes we're able to tackle this one. Dun, dun, dun. You ready, Fred? How much more massive would the Earth have to be for it to be impossible for any rocket to launch and enter into a stable Earth orbit? An extension of this question might be, how many habitable exoplanets are there that are perhaps too massive and or too resource poor to allow intelligent beings to leave their planet and colonize the galaxy? Nice question. Like it. So let's assume for a moment there is an intelligent race. They're as advanced as we are, or maybe, taking the sci-fi factor into account, they're far superior to us, but they can't get off because their planet's too big. Is that a possibility?
Nope.
There you go, Barry.
If you've got... So it all comes down to the escape velocity, which for the Earth is about 11 kilometers per second. You get a rocket accelerating away from the Earth at 11.2, I think, kilometers per second. It will never come back. It will leave the Earth's gravity altogether. And so as an object gets more and more massive, all that happens is the escape velocity goes up. And that, means that if you can build a rocket powerful enough, you can always get away. So for something the size of the sun, an object the size of the sun, the diameter and mass of the sun, the escape velocity is 618 kilometers per second. Now, that's a lot. It's faster than any spacecraft that we've built. But it doesn't, it's not infinite. It doesn't preclude an advanced civilization building a rocket if they lived on a planet the size of the sun and the mass of the sun. Then they have the technology to build a powerful enough rocket. That's what speed they need to get to leave the sun. The one I like, Andrew, is, and I think you and I have talked about this before, Mars's moon Phobos, the larger of Mars's two moons. The escape velocity is 40 kilometres an hour.
Yeah, a good hard push bike ride.
Yeah, push bike, that's right. But yeah, the sun's a bit more than that. So in that regard, there isn't a level at which it's impossible. Now, of course, planets generally are much smaller than stars, and that means that it's easier to get off them. So I don't think that there is any real purpose in investigating the question. The second part of the question: how many habitable exoplanets are there that are perhaps too massive and or too resource poor? That's a very different question, of course. To allow intelligent beings to leave their planet and colonize the galaxy. So I don't think there are any that are too massive. If you've got sufficient intelligence, you can build a spacecraft that could do it. Resource poor is a different question.
Yeah.
And I don't think we've got the answer.
If you land on, a third world planet, that's your bad luck, really.
A third solar system planet. That's right.
And I suppose the simple answer is where there's a will, there's a way. If they want to do it, they'll find a way.
That's right.
Okay. Barry, thanks for your question. Hopefully asked and answered. Next question, Fred, comes from Drew Harrison. Drew Forrester, I should say. Harrison, I think is his middle name, perhaps. Yes. He's a lawyer. I don't know why he's telling us that. What have we got? Have we got something to worry about, Drew? Anyway, he says, Professor Watson, thinking about the news in your most recent episode about the hypothesis that the planet 9 could possibly be a primordial black hole, it brings up the question, how large is the existential danger of a small black hole passing close enough to or through our solar system to throw Earth's orbit out of whack, as imagined in the novel Perihelion Summer by Greg Egan. You seem to mention that astronomers have asserted that the likelihood of it being a primordial black hole isn't much different from the likelihood of it being a previously rogue planet captured by our sun's gravity. Rogue planets sound common enough that if mini black holes with masses about the same size as planets are about as common, that sounds worrisome. Is it worrisome, Fred? Drew needs to know.
Well, yeah, he does, because he's a lawyer. And thank you very much, Drew. That is an interesting question.
Draw up the will, Drew.
The bottom line is we know that rogue planets exist. We don't know that primordial black holes exist. In fact, there is no evidence for them at all. All we have is a theoretical prediction that they could happen, they could exist. I'm just trying to remember what we said, though, that I think not necessarily the likelihood of Planet 9 being a primordial black hole.
I think you said it's as likely to be one as it is not to be one.
Yeah, but I think what all we were saying was that an object of the right mass either would do. That we're not, there's nothing in the evidence of the elongated asteroid orbits, Kuiper belt orbits, which is why we believe Planet 9 exists. There's nothing in that will differentiate between one or the other, as long as you've got something between 5 and 20 Earth masses. I think that was what we said, not necessarily that it's equally likely, although I could be corrected on that, because I say all kinds of rubbish when I'm on these podcasts, as you know, because you have to listen to it.
Charm, Fred.
No. But there is no evidence that we have a galaxy full of primordial black holes, and in fact, as I think I mentioned, maybe at the time, I can't remember whether we discussed this when we were talking about the Planet 9 issue, but the primordial black holes were postulated during the 1990s as perhaps being the source of the dark matter that we find in the universe, that perhaps we've got a universe that's littered with these things, and you don't see them because they're not shining, but they contribute significantly to the mass of the galaxy. And that was ruled out later in the 1990s by observations of what are called gravitational microlensing. Observations designed to find gravitational microlensing. When you've got an object passing, a gravitational object, whether it's a black hole or a star, faint star, passing in front of a distant star, and essentially it magnifies its light because you've got the distortion of space around it. Now, the expected levels of those microlens events from there being primordial black holes were simply not seen in the data when observations were made. So that was an experiment called MACHO, which was looking for the possibility of dark matter being MACHOs, massive compact halo objects. So in some ways, we've already ruled out, the primordial black holes as a culprit for dark matter. We might very well be able to rule it out as a culprit for Planet 9 too, especially if we find the real thing.
Well, yeah, and let's face it, we know there are planets in the universe, lots and lots and lots of planets. We know there are rogue planets in the universe, but we still have not yet seen a primordial black hole. So until we actually prove their existence, there's nothing to go on, is there?
Yeah, don't worry about it.
Pretty much. You can hold back on that will, Drew.
Yeah, but it's a great question. Good question.
Yes, indeed. And thank you for asking it. And we'll squeeze in one more. This should be a pretty quick question. And this comes from Nick Shack. Hello, Nick. Thanks for your question. Appreciate it. In regard to the Mars quakes that have been detected, I thought the core was dead. If there's no dynamo effect, what is causing the quakes? Tidal forces from its moons, perhaps, he asks. Good question, Nick.
Yeah, so it is a good question, but let's deal with the last bit first. It's not tidal forces from its moons because Phobos and Deimos, the two moons of Mars, are very small objects. And really, their tidal effect on Mars itself is pretty insignificant, even though they're relatively close to Mars.
I may not be thinking of the right thing, but is one of them potato-shaped?
Yeah, more or less. It's got a big.
Well, I mean, how tough's a potato? Come on.
They are. They're very porous. Oh, sorry. Phobos is an extremely porous object. It's 30 kilometers, 37 kilometers, or something across. As we've already discussed in this episode, it's got an escape velocity of about 40 kilometers an hour. It's very low gravity, so not tidal forces. Now, the sort of absence of a hot core is probably why Mars doesn't have a dynamo, that's right, because it has essentially no magnetic field. But it also doesn't have plate tectonics. And that's what the hot core of the Earth drives. It puts convection currents into the Earth's mantle, which move the plates around and cause them to collide. And of course, the collisions are what give us earthquakes, they are one of the principal causes of earthquakes. So you don't get that on Mars. Nick is quite right about that. So what the InSight spacecraft is listening for with its highly sensitive seismometer is Mars quakes that might come from shrinkage of the core, because Mars is cooling down, and as it cools, the core shrinks, or from meteorite impacts. That's another one that would likely produce Mars quakes. They're very, very, they're much less of a shaking than we have on Earth. And that seismometer is much more sensitive than earthly seismometers. It can actually pick up the wind blowing on Mars. And Mars does have strong winds. If you can describe anything in an atmospheric pressure, 1% of ours as being strong. So it's looking for other things, but it's still investigating essentially the internal makeup of the planet Mars.
Another thing that would cause a Mars quake is programming a rocket to fly there and putting the data in miles when you should have done it in kilometres. That would cause a Mars quake.
Yeah, probably, yeah, except unfortunately there wasn't a seismometer on them.
Yeah, but there's something really deep inside of Mars.
Yeah.
As a result of that mistake. Yeah. We're going to have to revisit that space stuff-ups. We did one segment in it on it a long time ago. It was so much fun. We're going to have to look up some more and do another segment on all the big failures. I don't know why I'm captivated by them, but I guess it's just, it's human.
Yes, it's human nature. We like.
But Nick, thanks so much for the question. Good one. And you're talking about my favourite place in the whole universe, Mars. So, I love talking about that planet. I think it's amazing. Just a beautiful, beautiful place. I had a desktop high resolution photograph of Mars on my computer at work for years. I just looked at it every day. Thought it was great. That sort of wraps us up, Fred. Thank you so much.
As Andrew drifts off to Mars, I'll stay here on Earth for a while. And
I wouldn't call it Earth where you are. It's Canberra.
Well, all right.
They might think they're the centre of the universe, but the rest of us know the truth. The truth is out there, Fred.
The truth is here, where I'm standing, right in the middle of
Canberra. If you say so. Thank you, Fred. We'll catch you next week.
Sounds great. All the best, Andrew, and good to talk again.
You too. Professor Fred Watson, an astronomer at large, joins us every week here on Space Nuts, and we thank you for doing the same. Join us again next week for another episode of the podcast we like to call Space Nuts.
You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.
With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone. With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.